Hello, welcome back. And today we are going to be shedding some light on object-oriented programming paradigm, what it is and why is it recommended to use in contemporary time if you're a developer or a programmer. So in order to understand what object-oriented programming paradigm, we need to understand what is an object. An object is a variable in which we store information data for a particular thing. That particular thing could be a person, a student, a car, that could be anything. For instance, I have stored a data for a science student in this object here. Her name is Alice. She is 20 years old and she has A grade and she's a science student. So I have stored a science student data in an object. We can skip this part, classes, and we can skip this part as well. We will discuss about these parts in the later part of our video. And as far as the attributes are concerned, she is 20, she has grade A, and she's a science student. These are her attributes. So in order to completely comprehend the concept of object-oriented programming paradigm, we need to understand the four primary tenets of OP programming language, which starts from encapsulation, abstraction, inheritance, polymorphism. So by encapsulation, we mean that we can bundle our data and methods within one class. And it also ensures that our data is protected. For example, if we want to make some changes to our data and want to make some changes to our methods, it won't be the external part of the application or the program outside the scope of the class that won't be affected. So it also provides us protection. So what do we mean by abstraction here? By abstraction, we mean that we are only concerned about the details that concerns us. For example, if we want to operate a car, we need to know the function of a steering wheel, and we need to know what transmission is, what is the function of the gearbox, and the levers down below, the pedal for acceleration and brake. If we know that we can drive a car, however, we are not concerned about the complex mechanical detail of the engine of the car. And I will be using OP instead of object-oriented programming paradigm for my convenience. And inheritance, it is quite self-explanatory. For example, a child inherits attributes from his or her parents. For example, the eye color, hair color, it is inheritance. Polymorphism, poly means many, morph means shapes. A thing, entity, or an object having more than one shapes. So these are the fundamental tenets, principle of object-oriented programming paradigm. So to work with it and to understand it. What are the benefits of using OP? I mean, of course, it provides us with the modularity. For example, if we are working on a complex application, we can divide our application's feature within different component or modules, which also ensures the reusability of the code. We can also maintain our code better. For example, if we talk about the reusability, we can use those same components within the entire application. Let's talk about some programming languages as well in order to get some idea that which languages do support object-oriented programming paradigm. For example, JavaScript is not a pure object-oriented programming language. I mean, it is a multi-paradigm language, which makes it a OP language as well, but still it is not considered as a pure object-oriented programming language. Ever since 2015, after the release of ES6 version of JavaScript, they have made it a object-oriented programming paradigm language as well. By the way, JavaScript is a high-level programming language, which is a dynamically typed language, which means that we do not need to define the data type every time we are writing the code. And so let's talk about the mid-level programming languages. Uh, Java, C++, C Sharp. Java is a pure object-oriented programming language, and so is C++ and C Sharp, but they are mid-level programming languages. For example, they are not dynamically typed language, you have to define their data types whenever you are writing the code or program. In Java and C++, C and C Sharp, and C, let's talk about the C. C programming language is a low to mid-level programming language, which is a imperative procedural language. It means that we have to define instructions for our program step by step. So it is not a object-oriented programming language. Assembler is a pure low-level programming language. I don't know much about assembler because I have never worked on assembler, but my hunch says that they use it for research purposes, and of course it is not a object-oriented programming language either. But I can surely say that this is the fastest programming language out there because it is a pure low-level programming language. By that I mean that this language interact with the CPU directly without any layers or compilers. For example, if we talk about the Java code has to be compiled with the help of its Java virtual machine. So there are so many layers that code has to go through if we are working on a mid-level programming language or a high-level programming language. At the end of the day, their code gets converted into binary form as well, and it communicates with the CPU as well. But due to those layers, they are not as fast as assembler or as C. C is also a very fast language, and C is extensively used in operating systems. For example, in the development of Linux, Windows, and Mac OS, and it is also used in embedded systems. For example, TV, cameras, and MRI machines. Also, it is used in performance critical application, for example, industrial automation and banking, perhaps banking as well. Let's not get carried away from our main topic today, which is object-oriented programming paradigm. And so I have written maybe more than 20 students' data here in the form of object, and I have done that statically. By statically, I mean that I have done that step by step. For example, if want to make I want to add another sports student here, which I'm doing right now, which is the static way of doing that. For example, I have a new student and I'm making an object for that student here to store her information, which is which could be very cumbersome in the long run and tedious as well. And since we are a human being, we are prone to make mistakes. If we are making the object step by step. So this is not the preferred way, by the way, if you are a developer. But I have made all these objects in order to give you an idea that how difficult it is to write the objects statically. It is not only time taking, it is kind of uh, error prone as well. Since we are human, when we are doing a repetitive task in the long run, we are prone to make mistakes. So so this is how we create objects statically, which is not the preferred way. So this is why we use instead of making the objects statically, we use object-oriented paradigm. So at the start of the video, I told you that we will be skipping these parts, classes, prototype, methods, methods as well. So now let's talk about these classes and prototypes, what they are, and how they do the work, how do they play their role in object-oriented paradigm. For example, I've taken a class here by the name of student, and I have taken a constructor here. When we talk about the constructor, it literally means that a thing that is solely made for constructing things. It is just there to make things. For example, if when we talk about the constructor, you can take it as that we are doing mass production on a assembly line in a factory. So this is what a constructor do. And we have taken a class of student which is acting as a prototype here. We can also call it as a blueprint. In factories, we have a prototype and we use that prototype to initiate or to initialize and to achieve mass production of a particular thing. So this is a prototype, a class, and in that class we have a constructor, and in that constructor we have passed parameters, like four parameters: name, age, grade, and major of that particular student. And it is expecting to get four parameter when we are going to be passing an input as an argument. So this is our prototype, and we are going to be using this prototype to be in order to store the data of our students. For example, if if I want to store the data of one student, two students, or perhaps three students, it's not a problem. I mean, it's an easy task. But as soon as I have to enter the data of 20 students at the same time, it would not be it would not only be time consuming, it would be inefficient, and perhaps in the long run, as it is a monotonous process, I will be committing mistakes. So when we use the constructor, and when we use the class constructor, the prototype, it is just like an automated process. Just it works as an automation. So it does not only saves us the time, but it also avoids us committing mistakes. So I have explained the prototype now, and let's talk about the method. So I have created a method here. So this method is just going to, I mean, get the information of the students, that I'm going to be storing their information with the help of this constructor. Again, I'm repeating myself because it is very important part. This is the prototype, and I will be using the constructor method to make 20 student objects, and I will be storing their information. And so this method is here. What is the task of this method here? So this method gets us the information of all the students that we will be creating out of this constructor, the prototype. Okay, so this is a method, and this is the prototype, and we have now discussed and explained the methods that we skipped in the first place when we started the video. However, let's shed some light on encapsulation as well. As I told you that in object-oriented paradigm, the class encapsulates methods and prototype. So as we can see that it starts from here and end here. The prototype is coming inside this class and as well as the method. So this is encapsulation. So you might be wondering what is this keyword here? This dot name equal to name. So this, I mean, this quote unquote keyword creates us an instance. For example, this name, this dot age, this dot grade. It is just creating us an instance in order to, when we create a new object, new, this keyword is used to to create a new object, and it uses these instances to make a new object. And this science student object, this student, is using this prototype, and it is also at the same time inheriting the 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 information that we have passed here. It is using this information to make a new student, its name, its age, its grade, so on and so forth. So it works irrespectively in an order. For example, we have taken student the name first, and given we have passed we are passing the name here first in an order. Then in the second place we have the name here, age. I'm sorry, this is age, and this is the grade. So this is how we are creating object by using this prototype, and this is inheriting these objects are inheriting the attributes from this prototype. So this is inheritance. So in the method, as you can see that we are returning the name of the student, the age of the student, the grade of the student, the major of the student. I mean, what what is the major of the student? If it is science, if it is arts, if it is commerce. I mean, so this is what this method is doing. It is returning us the information of a particular student, that what is his or her name, age, grade, and major. Okay, so we have created subclasses here. This is the major main class, and we have created subclasses here. Three subclasses here. Four. I'm sorry. There are we have created four subclasses here. One, two, three, four. One is for science students, and for example, we are creating a subclass, and we are using this prototype. Again, there's inheritance is happening here. We are we are using this prototype to create this subclass by the student science student to create science students class and differentiate that this student is going to be a science student. The same function is happening here. All it is the same thing for art student, but the difference here is just that I'm instead of science, I'm passing arts input to differentiate that these students belong to arts category. And in here, I'm passing commerce for commerce student, and here I am taking a sports student subclass as well, which is the last one, which is the fourth subclass, and I have four subclasses in total here. For sports students, I'm again using the prototype, the main class, since this is a little different than the other subclasses. So as you can see that if when we are creating a subclass of sports student using the prototype student, the constructor here is expecting five arguments, five input instead of four. But in the prototype we have four parameters. But here we are making this subclass, sports student subclass, to expect five parameters instead of four, because we have to differentiate the sports student category from the other subclasses. So this is why I have taken the sport parameter and I have called upon the constructor of the main class, which is this. And in order to create a parameter in the sports student category, I have created this instance here, this start sport, to create the objects for sports student and to store their data. So the sports student data is this. The objects for sports students are here, and we are storing their information. For example, this is David. He's 23. He has a grade of C. He has the major of science, but he also likes to play basketball. So this is how we are differentiating the sports student with commerce student only, because the commerce student are only focusing on their studies. They are not into any sports. Same goes to the other subclasses as well. Commerce students are being differentiated by arts, and arts students are being differentiated by science, by their majors. And we have taken taken another. I mean, it's not a new method. This is the same method. But since we have created a new instance here, so this is why we have to call this method again and return the get information from the super. We are using super dot get info in order to call upon this method here in this subclass to add the sport parameter into the sport student categories, sport student category. So this will override this will override this method, and it will give us updated information for students. So this is it for the inheritance part. And now we are going to be making objects. We will use the new keyword, and we will use this subclass, which is science student, and we will pass input, argument, name, age respectively. Like here the name is coming first, age is second, grade is third, and major is at the fourth number. So we have to pass the input respectively, like name comes first, Alice, age, and grade. Same goes to the art student, and same goes to the commerce, and same goes to the sports student. And I have taken a for each. I'm just using a for each loop on this array of object. This entire thing is an array of object to to get the information of each student. And since this entire data structure ends here, so let's run this function. So you can see that the the science students have science as a major. The arts has arts as a major. Commerce student has the commerce as its major. And the students who are involved in the sports, they might have science, they might have arts, they might have commerce, but they are also at the same time involved in sports. This is why I have to m- make a new instance for parameter, the fifth parameter to I mean to in order to know that students are playing. And what about the polymorphism? We haven't talked about that since we are already running this data structure and we are getting all the information, but we haven't talked about the polymorphism, if it is taking place here or not. It indeed is taking place in the entire data structure. For example, as I told you, what do we mean by polymorphism? Poly means many, morph means shapes. So this is the main class, the prototype, and we are using this prototype to make many shapes. I mean, this is the main thing, main prototype, and we are using the same thing, using this prototype to make subclasses who has different attributes, like art student, like science student, like commerce, like sports. So indeed, polymorphism is also taking place here. And I haven't used any dynamic maths or logical gates, conditionals, and I mean conditions, and I mean I haven't used any algorithms here. So I'm just going to give you an example. For example, if you combine if you combine this algorithm with this data structure, it becomes data structure and algorithm. And congratulations, you have learned what data structure and algorithm is. Thank you.